Good morning, everyone. I'm Greg, and I'll be your room host for today. I'd like to welcome you all to the first sponsored session by Palo Alto. So I'd like to welcome the Cloud-Focused Security for Speed and Scale by Sebastian Sala.
Alrighty, thanks for that. So look, before we get into it, I'd just like to acknowledge the traditional owners of the land on which we meet today, both elders past and present. Now, like it was mentioned, my name's Sebastian Sala, and I'm a cloud security architect at Palo Alto Networks. I focus pretty heavily on cloud security, and in particular, security of AWS environments. Now, the purpose of today's talk is to really showcase how Palo Alto Networks can work with AWS to provide you best-of-breed protections where you need them most. Now, in terms of how Palo Alto Networks does that and how it can enhance AWS's protections, it's really across three pillars of security, namely cloud security, SOC security, and network security. Now, we're going to be delving pretty deeply into cloud security during this presentation, but if we just focus for a second on SOC security and network security, these can also help bolster your cloud security posture. Now, in the SOC security space, this is where we've got a range of tooling that can help SOC analysts and engineers with identifying and remediating security incidents. So this comes in the form of extended detection and response tooling, so XDR, as well as security orchestration, automation, and response. So SOAR tooling, right? That's where we've got out-of-the-box playbooks against hundreds of different scenarios that could take place. And then finally, we also have attack surface management tooling, where we're essentially scouring the internet on a daily basis, trying to find public assets, and trying to understand if they're vulnerable, misconfigured, or ultimately a risk to your organization. Now, in the network security space, this is probably what you already know Palo Alto Networks for, our firewalls, right? These can be deployed in both physical formats in your private data centers, but importantly for AWS, they can be deployed in virtual formats and also containerized formats. So they can be deployed on top of AWS and even within your Kubernetes clusters. Now, some of the neat things here are that wherever possible, we've created integrations between these different toolings, right? So Prisma Cloud, which is something we'll be going into shortly, which is our cloud security tooling, can potentially flag an alert for a potentially compromised workload, feed that alert through a native integration into our SOAR tooling, so Cortex XSOAR, which would then kick off a playbook to then implement a prohibitive firewall rule set that would ultimately isolate or quarantine that workload from the rest of your network. And those integrations extend across both our XDR toolings and attack surface management toolings as well. Now, in terms of why you would want to partner with Palo Alto Networks as a company, it's because we're an AWS advanced technology partner against a range of different disciplines, including security, containers, DevOps, as well as networking. We also, out of the box, integrate with dozens of different AWS services, far more than what is listed on screen here. There's just too many to get on a single slide. And we've been working with AWS for years, right? So we have a pretty mature implementation where we can not only identify misconfigurations, anomalies, and threats for these different AWS services, but we can also add an auto remediation action. So if we identify a misconfiguration or a threat, we can take that action based off of your input. Now, that's a good segue into the shared responsibilities model, and I'm sure everyone here has probably seen this 100 times, so I'll be pretty brief, but the main thing here is when you're adopting AWS infrastructure, AWS will secure the underlying infrastructure that you're using. So if you're deploying like a workload, an EC2 instance, they'll make sure it's deployed in a physically secure location, the server rack that it's hosted in is secure itself, that they're isolating different customer networks virtually on that server rack as well. But when you're implementing that EC2 instance, it's your responsibility to ensure that the volume storage being used is encrypted at rest, you've set up a backup plan, you've not implemented overly permissive security groups which are unnecessarily exposing that workload to the public web, and so on and so forth, right? So it's a shared responsibility. And ultimately, Prisma Cloud can help you with your responsibilities in the cloud. Now, what we've listed here on screen are essentially three key challenges that a lot of our customers are facing when they're building cloud-native applications and trying to keep them secure, right? So the first one over on the left with new cloud-native architectures. Essentially what we're referring to here are the various forms of compute being used in the cloud today. So if we were to go back 5 or 10 years and ask somebody in IT what a form of compute was, they'd probably say it's a physical machine or a virtual machine. But In modern environments, and particularly in cloud-native environments, we've got a growing use of containerized architectures as well as serverless functions. And the main thing here is, regardless of the form of compute in use, we need to have a consistent approach to runtime protection, right? We can have a web app that's hosted on a physical box, a virtual machine, a container. You could be using serverless functions as a web API backend, but they're all still going to be vulnerable to many of those same application-level attacks. So we need that consistent approach. When we're looking at that second challenge there with DevOps driving constant change, what we're really referring to here is how the application development lifecycle has changed, right? And this is especially relevant in the cloud world, because if we go back even just 3 to 5 years, or we look at how many federal government and defense agencies implement applications today, particularly in on-premise environments, there's like half a dozen or more different teams involved in the application development process. We've got Wintel and Linux teams managing Windows and Linux fleets, infrastructure teams assigning compute, network teams managing firewalls and route tables and subnets. We've got database teams administering databases, security teams over the top approving everything, and then, of course, you've got your developers actually developing the application. But in the cloud world, typically what I've seen are developers have transformed into DevOps engineers, and they've sort of got carte blanche to do what they want, right? They're not only developing the application that is providing the core functionality for what they're providing, but they're also picking and choosing what infrastructure to use. They're choosing whether or not it's going to be deployed on top of EC2 or containerized architectures. They're choosing if they're going to be using S3 buckets or RDS databases or DynamoDB databases and so on and so forth. So the challenge here is really, when developers are given all of that ability to deploy, they may know how to deploy, but they may not know how to deploy in line with industry best practices. And we can't really expect them to, because there might be dozens of different AWS services they might be leveraging, and they don't have all of that domain expertise that those half a dozen different teams were providing historically. And that final challenge there sort of comes hand in glove with the second challenge, security teams getting left behind. So historically, an approach to security has been doing sort of point-in-time assessments, right? You get an IR assessor comes through, ANAO auditor, whatever it be, internal audits. They do a point-in-time assessment, you get fed a report, and boom, you know, there's the next 6 months of work. But in the clouds, when you've potentially got new versions of applications being released on a more than daily basis, you need to make sure that you're actually continuously maintaining a live stream of updates of what are your compliance issues, what are your vulnerabilities, what sort of threats are you dealing with at this very point in time. So that's a challenge that security teams are dealing with. Now, when we look at what Prisma Cloud delivers, it's 4 pillars of capability that really address those 3 key challenges. So what I'll do is I'll just provide a brief overview of what we're providing here, and then we'll deep dive into some of the different functionalities. So I'll start off with that second pillar there for cloud security posture management. Essentially what we're doing here is we're integrating with AWS through an API-driven approach. We can integrate with single accounts, organizations. We can integrate with multiple organizations and multiple distinct accounts. We'll collate all of your assets across all of those accounts and regions into a single unified dashboard, and then we will analyze those assets against about 1,200 different out-of-the-box policies. And we also align to about 55 odd compliance frameworks for those policies. So in particular, the ISM, Essential 8, AES CSF, APRA CPS 234, and then pretty much every global compliance standard you can think of. So NIST CSF, ISO 27001, PCI DSS, and the list goes on and on. We also provide a threat detection capability here, so we can monitor VPC flow logging to detect anomalous activity between your workloads, and also implement a data security capability, so we can monitor your S3 buckets for sensitive data, as well as potentially malware that might be residing on them at rest. Now, that first capability over on the left with cloud code security, this is where we're essentially trying to perform many of those cloud security posture management functions just earlier in the software development lifecycle. So we have to keep in mind, with that second pillar there, that is an API-based integration into AWS. So we're essentially scanning your live assets for misconfigurations, anomalies, and threats. But ultimately, they are deployed assets. So in many cases, a risk is potentially already realized, right? If you've got a S3 bucket that's publicly accessible, that's a running risk. But in the cloud, a lot of developers and application developers are using infrastructure as code. So Terraform templates, CloudFormation, CDK templates, whatever it be. So ultimately, what we can do with this first pillar on the left with cloud code security is we can integrate with the developer's tools to scan those templates during the software development lifecycle. So we've got tools for IDEs like VS Code and IntelliJ, where we can essentially provide IntelliSense to developers as they're coding those templates. We can integrate with code repos like GitHub, GitLab, AWS Code Commit, bit of a slip of the tongue there, to essentially look for pull requests and programmatically inject comments if we detect misconfigurations within the infrastructure as code templates in there. And we can also integrate with code pipelines. So AWS Code Pipeline, Jenkins, GitLab, GitHub Actions, insert your preferred CI/CD tooling, and we can fail builds if we detect misconfigurations there. This is where we can also scan container images, right? So we can do those same checks for container images, where we'll scan for malware that might be backdoored into an image, compliance issues, as well as vulnerabilities, right? So it's a pretty expansive capability. With the third pillar there, cloud workload protection, this is where we can protect at runtime all the various forms of AWS compute, whether it be an EC2 instance, a container that's running on a standalone host, if you're using EKS, Fargate, ECS, and even Lambda. We've got runtime protection capabilities available in both agent-based and agentless approaches. And I'll delve deeper into the capabilities there shortly. And the final piece there, cloud identity security, this is where we essentially look to try and simplify the process of managing AWS identities, right? So in AWS, an identity can be a user or a resource, and there can be a variety of ways that a user or a resource could be assigned privileges, right? You can have a user that has a group assigned to them, which then has a role attached to it, which then has permissions within it. You can have a resource with a role attached to it. Resources can have ACLs within them. You can have service control policies coming over the top with explicit denies. And if it sounds complex, it's because it is, right? So what we've done here is we've built an effective permissions engine where you can plug in like a user ID or a resource ID or even a set of permissions, and we'll allow you to monitor that user, resource, or set of permissions. Now, in terms of if we look at those pillars of capability just in a different format, this is sort of what it ends up looking like, right? So we've got the build phase all the way over on the left. That's where we've got our integrations into IDE toolings as well as code repo technologies for performing infrastructure as code scanning as well as scanning of container images. During the deploy phase, that's where we're integrating with CI pipelines. And then during the run phase, that's where we're doing those API-based integrations into AWS, as well as performing those agent-based scans, right? So there's a range of capabilities there. Now, pretty much everything I've spoken about so far are all capabilities that fit into the Gartner acronym of Cloud Native Application Protection Platform. But really what makes us different is sort of what you see on screen here. So those pillars of capability I spoke about are all available from a single unified console, right? You don't need to manage multiple different tool sets. We've got both agent-based and agentless approaches to runtime security as well. So essentially the distinction here is an agentless approach is where we don't need to get an agent onto your form of compute. We can leverage AWS APIs to do scanning. So an example here is if we want to identify vulnerabilities and compliance issues on an EC2 instance, option one, you can use an agent and then we can scan the libraries on that running workload. Or option two, we can leverage AWS APIs. We can take a snapshot of that running workload. We can then again, using the API, scan that snapshot statically for vulnerabilities within it, as well as compliance issues and even malware that might be residing at rest on it. Now, there are benefits to going with an agent-based approach versus agentless, which is something I'll delve into shortly, but that's sort of the delineation. Now, in terms of third-party toolings that we can integrate with, there are a variety of native integrations out of the box, right? With Splunk, ServiceNow, Teams, Jira, insert sort of whatever workflow or incident response tooling you're using. But we can ultimately integrate with just about anything through a custom webhook approach. And finally, we've got approaches essentially from what we say code to cloud, right? So we can integrate with every single stage of the software development lifecycle, from the IDE that developers are coding in, to the code repos, to the CI pipelines, ultimately into an AWS hook, into an API hook into AWS. Now, if we take a deeper look at what we're doing with runtime protection and that agent-based approach, sort of what you see here on screen are the various forms of AWS compute that we can provide runtime protection for. So I'll just quickly run through sort of our approach to it because it does differ depending on the form of compute we're protecting. So when we're looking at EC2 instances, this is a very traditional approach to runtime security. We've got a single host, we get a single agent on it, and through that, we're providing runtime protection. When we're looking at containerized architectures, though, we sort of differ that. Right? So what we'll end up doing is if we're protecting like a Kubernetes cluster or even just a standalone host with containers on it, we'll deploy our agent as a container within it. And then through that, we'll be able to protect all other containers and the host itself. So essentially, we're transitioning from that one-to-one to a one-to-many approach. Now, when we're protecting Kubernetes clusters, we also deploy as a daemon set. So whenever we see a new node spin up, we'll just programmatically inject our container and protect essentially every node within that cluster. When you're using technologies like AWS Fargate, we can deploy as like a sidecar task. So essentially, it's back to that one-to-one approach, but that's necessary because the orchestration capability is sort of abstracted away. Now, finally, with Lambda, we can either embed directly in a Lambda function through libraries we've got available for C#, Python, Node.js, and so on and so forth, or we can even just, again, using AWS APIs, programmatically inject a Lambda layer, and then we essentially take over as the entry point within that Lambda function and provide runtime security over the top. Now, if I just briefly recap some of the highlights of what we've spoken about. So in the cloud code security space, the main thing to take from here is that we've got those integrations across the various forms of the software development lifecycle. We can scan for infrastructure as code misconfigurations, as well as container images, compliance issues within them, vulnerabilities, as well as malware that might be backdoored into them. When we're looking at cloud security posture management here, we can integrate with AWS through that API-driven approach. We've got about 1,200 policies out of the box. You can create your own custom policies. We've got essentially what we call our resource query language, where you can just essentially code together your own custom searches within AWS. And we align to about 55 different compliance frameworks. Importantly, we've got the localized compliance frameworks for the ISM, Essential 8, and so on and so forth there. When we look at cloud workload protection, this is where we've got those agent-based and agentless approaches. And just sort of recapping what we're providing, we've got anti-malware protection at runtime, so we can prevent malware from executing. We've also got process control, file control, and network control capabilities on top of hosts, containers, and serverless functions. And the neat thing for containers, what we can end up doing is allowing you to fulfill your application control requirements. And the way that we do that is whenever we see a new container spin up in your environment, we will monitor that container for a 24-hour period. We'll then baseline known safe activity based off of the first 24 hours of what we saw, right? So if we see a container spin up and it's executing various commands, we'll assume that within that 24 hours, it's safe and trusted. And then we'll create that baseline, lock it down, and then we can either raise alerts, prevent any additional processes from kicking off, or even just terminate the container and assume it's been compromised if we see anything outside of that known safe baseline. And then, we've also got runtime security checks there as well, so we can align predominantly to like CIS hardening benchmarks for hosts, containers, and even serverless functions. And then finally, in the cloud infrastructure entitlement management space, IAM security essentially, that's where we've got our net effective permissions engine for essentially simplifying the process of managing your AWS identities. Now, one thing I want to go through here in this sort of final use case is something called a continuous authority to operate. And this is something that is hugely popular over in the US, particularly with US DoD. And essentially the idea behind it is US DoD wants to streamline and simplify the application development process for developing and deploying mission-critical applications. And the way that they're going about this is they've essentially created an enterprise shared service called Platform One, right? And if anyone here has heard of Platform One, it's essentially an environment where there is a range of DevSecOps toolings, right, that come in the form of managed CI/CD pipelines, container registry of known safe images that can be utilized, as well as a variety of other capabilities that essentially anyone in the US DoD portfolio can come and leverage. Now, essentially, with Prisma Cloud, we can help enable a continuous authority to operate model within Australian DoD and FedGov as well, right? So essentially, the idea behind that is instead of sort of doing point-in-time assessments, which is what's currently done with an authority to operate, you instead implement DevSecOps tooling, so that way when developers are coding and developing their applications, they're continuously assuring that those applications are secure against vulnerabilities, compliance issues, runtime compliance-related issues, pretty much everything you see on screen there, right? So ultimately, you end up with a benefit on both ends, right? Because if we go with just the sort of standard authority to operate approach, okay, there we go. What ends up happening is developers end up creating a big backlog of vulnerabilities because essentially they don't get notified about it until a point-in-time assessment is done. It could be 2, 3, 4 months down the line, and then they'll potentially have to spend weeks or months going through their application, figuring out where those vulnerabilities are getting introduced, and essentially just retrofit their application to be compliant. But through that continuous authority to operate, you're going to assure that it's continuously compliant, right? You've got the DevOps toolings to provide developers with that notification before they actually deploy. And yeah, what you can see on screen there, we've got infrastructure as code security capabilities. We can scan for container image misconfigurations. We've also got a sandboxing capability, and we can also scan for IAM security related issues. Otherwise, that's all I wanted to go through. In terms of some additional resources, what you can see on screen here is essentially anything that you can go and publicly access in relation to Palo Alto Networks resources, as well as Prisma Cloud resources. But otherwise, I'm happy to take any questions anyone might have. Yeah. Cool. It's always easy when there's no questions. No. Perfect. All right. Otherwise, look, thanks for coming.
So, obviously, diving network information to the site, models, stuff like that. I'm just wondering when it comes down to like customers and companies' security zoning model, i.e., you've got network security groups, you've got various ways to do the workloads. How do you go about coming together using that tool to say, you know, if I restrict the workload, I'm talking to my public network, I'm talking to my, you know, on-prem network, on-prem. Those kind of almost like a compliance tool set for a zoning model within the company.
Yeah, sorry, I missed some of what you said there.
No, it's all right, my throat's kind of dead from last night. What I was more going about was in the networking layer, obviously when you look at securing workloads, obviously north, south, east, west flows.
Yep.
Would this tool help with that kind of compliance to say, okay, I have restricted database, I don't want it talking to my public network or a public Lambda, and some developers come in and go, you know what, it's a pain in the ass, I'm just going to open up a security group to allow that access to flow. Is there a way we can obviously monitor for that, comply for that, and switch as part of that workload?
Yeah, definitely. So yeah, you can create custom searches where you can essentially look for security groups that are provisioning access to certain subnets or VPCs. But I would say with that approach, you're probably best off going to be just going with a firewall and deploying it between your sort of VPCs and monitoring traffic between them.
Hi. So you mentioned about the threat detection capability within Prisma, and so AWS natively provides the guard duty, which I would say provides the same network threat detection capability.
Yep.
So for a customer using Prisma, should they be looking at both the alerts basically, or they are better off with one?
Yeah, no,
service?
That's a good question. So we do have a native integration with Guard Duty, Inspector, and a few other sort of native services within AWS. You don't really have to do anything to set up this integration. As long as we've got the permissions to hook into Guard Duty, we will pull in Guard Duty alert information as well. And Guard Duty is still beneficial, right? So we can work on top of Guard Duty. I suppose the way that we play on top of it is within Prisma Cloud and within our threat detection capability, we're actually leveraging multiple different capabilities. So like one portion of it would be the threat detection of monitoring like VPC flow log data, which is something that Guard Duty does. But then we go on top of that through correlating vulnerabilities. So like what we can end up doing is creating a custom alert to say if we have a workload that is communicating to suspicious IPs, and we can also see that that workload has host-based vulnerabilities on it, let's raise an alert around that, right? So we can help add some additional context around Guard Duty alerts with data that Prisma Cloud is also providing. Cool. Any other questions? Well, I think we'll leave it there. Thanks everyone for coming.